Welcome to all. This is part 6. Actually, in the thumbnail you can see it. This is part 6 of analysis of singly and doubly reinforced rectangular sections by working test method in general. Whereas for the RCC group or batch, it is class number 20A. Why it is 20A? This I will explain to them in the group. Others need not bother. See, you can see in the title you can see this one. But in the thumbnail you can see part 6. You follow other people or follow the part number. Don't worry about the class number all. Okay. Analysis of doubly reinforced rectangle section by working test method. Remember the principle why doubly reinforced section is required, etc., and also the basic equations or derivation of expression for m in terms of stresses, location of neutral axis, etc. Everything is covered in the basic, in the regular class. This class is meant only for analysis example. I will write some equation here. Nobody should ask how that equation came. It is derived in the class. So here that is only for numerical part. Expressions given by me are to be considered to be correct by everybody. It is always correct only. Okay. Now, see there first. Bending moment can be sagging or hogging. This I am telling from beginning. If sagging, compression at the top, tension bottom. So therefore, tension side AST is here. See, AST is always there. Compression side steel, because this is doubly reinforced. Doubly reinforced means steel reinforcement is provided not only in tension side is always there, also extra or additional steel in the compression side. That is ASC. I think I have not written that. I forgot, right? I'll write it down. Okay, over. Now, here, hogging BM, top tension, bottom compression. Okay. Now, further, what this is called? Why I am writing? Because recently I saw somebody telling, someone told this is neutral axis. No, it is not neutral axis. It is in the, when you see the bending this way, what you are seeing is not neutral axis. I call it either neutral plane or neutral layer or some neutral level. It is not neutral axis. Neutral axis comes in the cross section. See, if you cut the cross section, what you are seeing is neutral axis. Oh, this I will tell in a separate class, not for RCC, general, little later. Okay, start. Now, I written all the meaning there. See, first do one thing. You consider the properties for singly reinforced section. Imagine AS is not there. B, both the sketches same, breadth or width. Capital D, overall depth. AST, here bottom, here top. Area of cross-sectional area of steel in tension. D, effective depth. Extreme compression edge. Sagging means top edge. Hogging means bottom edge. From there to center of AST is effective depth. So, effective depth is written here, distance of centroid of tension steel from extreme compression edge equal to D minus C. No space here. Effective cover to tension reinforcement, you should write, which is distance of centroid of tension steel from extreme tension edge. See, here, I forgot right here. This is your, I forgot right, I'll write here. This is your effective cover to ECT, effective cover to tension reinforcement. Okay, over. M is the modular ratio. Remember, in single reinforced section, steel is only on tension side. For that, for equivalent, you apply M. So remember, the M you are using is modular ratio applicable to tension steel. Class means what M we considered earlier. If given means take given value. Or 280 by 3 sigma CBC. That is the modular ratio to be applied for tension steel. For converting tension steel to equivalent concrete, or divide the stress in tension steel by M, you get stress for equivalent concrete, or M stands for applicable to tension steel. I will tell you why I am telling. Okay, then further, class, from there, not over, go there, means here. Class, MC is modular ratio in compression side. So now you require one more term called modular ratio in compression side. As per IS code, MC equal to 1.5 times M. So IS code has given modular ratio for compression side is 50% more than that for tension side. That's all. Reason I told in the regular class. Okay, class something. But remember one note, even though the conversion here is by MC, actually you do MC minus 1. Later MC minus 1 ASC will come. Why subtract 1? In the regular class I told, I think I told example of rupee and dollar, if you remember. So remember that one. Others, formula, that's all. Then also note, see, class, once again, FCBC, sorry, now, one, I forgot right here. I should have written that one. Okay, now I will add that one. Okay, I will, little later I will write. Or shall I write now? This much over. This much over. Okay, I write here. Further, FCBC is maximum stress. Did I write it already? No. Maximum stress. Maximum stress in compression. Maximum stress in concrete in bending compression. Bending compression. And which will be at the extreme, right here, which will be at the extreme compression edge. And FST is stress in steel in tension. In tension. So just 1 minute. Let me check. Did it go out of the camera? Because later, no, correctly it came. No problem. Okay. This extra. Further I will write this one. And then I write one more statement, important. Let X be depth of neutral axis. Space is here. Let X be depth of neutral axis. Neutral axis. Space is not there, right? That is same as last time. Distance of neutral axis from extreme compression edge. See, extreme compression to neutral axis is X here. This is X. These are the property for singly earlier. Okay, then further, before you go to W part now, one important. See, don't worry about that ASC, D dash, FC dash. Do not bother about those things now. See here. FCBC by X equal to FST by M divided by D minus X. Also note, class. Again, class means this is using this relation we derived the concept of balance section, under reinforced section, over reinforced section, etc. And also later permissible stresses. For under reinforced what happens, or for balanced what happens, for under reinforced what happens, for over reinforced what happens, all we discussed earlier. See, now, therefore, all these concepts of what? Balanced, under reinforced, URI means under reinforced or over reinforced, and also regarding permissible stresses are all valid here also. Why I am telling now? So, all those principles are valid here also. The only change here is expression for neutral axis and expression for M will have additional terms. That's all. Expression for neutral axis and expression for M will have additional terms. I will tell that one. So I think everything is clear now. Okay, now further statement I require. I think space not there. I will write somewhere here. See, this all I am removing now. Everything I am removing. See, FCBC, FST by M. Here also, FST by M top, FC top is little down. This is stress distribution across cross section for equivalent concrete area. Stress distribution across cross section for equivalent concrete area. Write it. Don't put DACA, FIA like that. correctly write that one. Okay, 1 minute now. I think everything has been explained here. All, see, everything is clear now. I forgot right here. Here, this is tension, this is compression. Now, little later, I will tell one more thing. FC dash. See, I am rubbing the board now. The board I am rubbing now. Therefore, a term called FC dash will come. That is, now little later I will write extra terms now. ASC, because I am writing after the second round. But by that time, sketch will not be there. You can see now only. ASC, area of steel in compression. So, I have to now explain ASC, one term. Okay. Area of steel in compression. Then, next term will be D dash. D dash, distance of centroid of compression steel from extreme compression edge. Or, your D dash will also become effective cover to compression steel. Okay. See here, D dash here, ASC here, ASC here, D dash here. Little further, in the second round, when I rub the board, I will tell one more term, FC dash. Here, FC dash. I will explain now, right later. FC dash is compressive stress in not steel, in concrete. See, here it is extreme fiber stress is FCBC. From here, come down to D dash, come down, not down, come towards neutral axis by D dash or reach the level of ASC. At that level, see, in the concrete, not in steel, compressive stress in concrete, conversion is there. Compressive, I used FC, not FSC. In limit state method, we don't use conversion. There you use FSC, if you remember. The stress in compression steel, limit state method, we tell FSC. Why? There is no modular ratio there. Okay, so FC dash, see here, this is FCBC, this compression remove, I'll put somewhere here, obstructing. Okay. FC dash is, so I next explain FC dash in the board. Compressive stress in concrete at the level of centroid of compression steel. So remember, FC dash is stress in concrete, where not extreme fiber, you come towards neutral axis by D dash, or where is the centroid of the ASC is there, stress is called FC dash. I think X over, I think nothing further required. If anything is required, WH post part I am telling now. Other things are single end post part. Already told from class 1, part 1 to part 5. You can go through. I think over. I will now, because I am rubbing the full board now and writing all expression today. And next class, class number 7, I will start examples. Class 7, I will go for stress calculation. Class 8, MR for singly. MR for under rainbow section. Class 9, MR for over rainbow section. Class 10, I will tell, some people will tell, tension, based on tension, you cannot obtain equation for either M. I will prove them it is wrong. Extra information or anywhere I may put inside. I may put it somewhere in between. Okay, now I will go for next round. Remember, when I go to next round, none of this will be here. And one more thing. Later, when you want to find the FC dash, what you have to do is, you use similar triangles. See, I will tell here only now. Next time I will tell, explained already earlier. See, I write here only now. See, if you see the similar triangle here, it's not complete. Right. See, this is X. If that is X, this will become what? X minus D dash. Same here also. This will become X minus D dash. So, here, use similar triangles. You get FCBC divided by X equal to FC dash divided by X minus D dash. Or, if you simplify, it will become what? It will become FC dash equal to FCBC into X minus D dash divided by X. Now, go to limit state method. In limit state method, you require strain in concrete at the level of strain in steel, compression steel, which is nothing but strain in concrete at that level. See, concrete stress, extreme fiber concrete stress into X minus D dash by X. There it is 0.0035 extreme fiber concrete strain into XU minus D dash divided by XU. Oh, some will tell, oh yes sir, yes, here also same. Here stress, there strain. That reason it will come in limit state method. Okay, over. Now I will go to equation. Today I decided, because it is a little short class. If I write everything on the board, it will take only 2 minutes to explain. No. Today I decided I will write equation in front of you only. See, as I told, I don't require any reference. So I will keep on writing here because, but remember, when I write everything, you should not think it is by-hearted. By-hearting I am so weak. Once I write some numerical here, if I look this way, I forget the numerical. Page number or IS code, still I am not able to tell. So it is actually what I am writing is based on derivation. Derivation I can see. When I see, I don't have to see somewhere. It to the mind that feeling will come. Based on that one, I write a full procedure now. Just another not 2 minutes for you. It's a pause only. Okay. Now I will write here procedure for analysis. Procedure for analysis. See, after this class is over, everything thoroughly I have to go through. I just the camera. This is by chance out of the camera, I should check. No problem. See, first step. See, I tell you, this is for both. For both means Roman 1. What Roman 1? To find stresses. To find stresses developed. This all I told earlier. Stresses developed. When cross section is subjected to bending moment M. Second, Roman 2 is the most important. You will be knowing by this time. Roman 2 is to find MR for given cross section. Given cross section. This also when right here, given cross section. Okay, it's important. When the word given is important, given cross section is subjected. So for both of them, procedure. See now, procedure analysis for both first. For both. Now, okay. Instead of that, for both I will do one thing now. Okay. Instead of that, I will write here. See, first step. Don't wait. First, locate neutral axis. Locate neutral axis. That is, find the value of x. X. Remember, x is depth of actual neutral axis. See, I told x is green, always blue color. Actual neutral axis for given cross section. Now forgot. For this one, it is common procedure. Common. That is right here. Whether for Roman 1 or Roman 2, for both Roman 1 and Roman 2, whether you are interested in finding stresses developed or finding MR, neutral axis, you know earlier, equation is, I will put the equation to locate neutral axis is B, see, as usual, neutral axis blue color. B into x square by 2 plus, see earlier, bx square by 2 equal to MAST d minus x. Now, compression side one more. MC minus 1. Remember, I told in the earlier regular class, y minus 1. MC minus 1 into ASC into x minus, see what I am doing here? I am seeing the distances. X minus d dash equal to m times AST into d minus x. This is the equation to locate neutral axis. This will be a quadratic equation. Solve and get x. Okay. That x is Once again, depth of actual neutral axis. Okay. Now, one small important. You just put ASC equal to 0 here. Means W will become singly. Then what happens? Bx square by 2 equal to MAST into D minus X. Same as that one. So, for doubly reinforced section, compression side, there will be additional term. Okay, now, this over. This is to locate neutral axis. Okay, now, I'll rub the board because I want more space now. Or I'll try. Now, for Roman 1, that is to find stresses developed. I told 1,000 times. Random bending moment. We are not bothered about what? Strength. Whatever you eat, pay for it. To find stresses developed. When, one thing forgotten, I already told you, MC equal to what? I already told you. MC equal to 1.5 times M. I already told you. Okay. To find stresses developed when given cross section is subjected to bending moment M. Okay, now one note. Before going further, those extra terms I should tell now. I forgot. Some extra terms are required. I will write here. One of them is D dash, ASC. First, I forgot to tell ASC here. ASC is cross-sectional area. I should have, actually before starting, I should have given cross-sectional area of steel in compression. You should do one thing. You first write this one. Before you start here, write this one. Then D dash is distance of centroid of compression steel from extreme compression edge, or you can tell D dash is effective cover to compression steel. Just camera checking. It's a problem. Sometimes what happens is by mistake goes light out of camera. I regret it. Okay, now last term required. Last term required is FC dash is compressive stress in concrete at the level of centroid of compression steel. Right, further, how to get it? Use similar triangles. Just now, already explained. What do you write? FCBC divided by X equal to FC dash divided by X minus D dash, or you can tell FC dash equal to FCBC into X minus D dash divided by X. Okay, these are forgotten. I wrote just now. Now, I want to clean everything now so that I will give the two. I mean, what now? One not required. Right? 1 minute. Okay, now right now I am telling to find stresses. I will complete this one now. Okay, now note. When you find stresses developed, you are not right here. You should write. We are not bothered about balance. I should not tell all these things. See, we are not bothered about balance section, under reinforced section, over reinforced section, permissible stresses. None of them you are bothered. Apply the bending moment and find the stresses. Over. Now, one extra note. In case of singly reinforced section, we have expression for M based on compression and also tension. But you write all these things, you write it. But in case of W reinforced section, we get easy expression in terms of compression. But direct expression in terms of tension is not available. Reason I told in the regular class. For you not available. But it is not impossible. I will show you later it is possible. But therefore, I told earlier also, WI in post section, you use M in terms of only compression. Okay. The equation is, we have M equal to, same way, B into X into FCBC by 2 into bracket D minus, see, X is blue color, X by 3 plus extra terms MC minus 1 into ASC into FC dash into D minus D dash. 1 minute. MC minus 1 into AC equivalent area, FC dash force into arm. Okay, correct. Where M is the bending moment for the cross section and FCBC is what? How much, what is FCBC is what? Maximum compressive stress developed in concrete due to that, or when given cross section is subjected to bending moment M. This is the definition. Okay, now what to do FC dash I will tell in the class. So this is the expression for M. Remember, substitute for M, get FCBC. Okay, using this equation, find FCBC. Okay, once you find FCBC using this equation, 1 minute, eraser, okay, right here. Once you find FCBC using this equation, I'll write here. Okay, this I'll remove now. I'll continue. Then, to get FST means what? Stress developed in steel in tension due to bending moment M for cross section. You can make a note. If it is singly reinforced equation, we got an expression, namely M. This is not writing. Okay. If it is singly reinforced, we have expression M equal to AST FST into D minus X by 3. No, this is not applicable. The expression for M in terms of tension is little complicated. So what you do is, no, first you find FCBC. Okay, therefore, easily to get FST, what? Just now, we got FCBC. Use relation between FCBC and FST. That is M times FCBC divided by X. Divided by FST. X, anything will do. Divided by FST equal to X divided by D minus X. Here, substitute for FCBC and get FST. This I told earlier also. This way you proceed further to get FST. Suppose, right here, suppose stress in compression steel required, what to do? I will tell in the class. I cannot explain here because it will not be clear so easily. In the example I will tell you. Suppose question is, what is the stress in compression steel? In the class I will tell. Okay. This is procedure to find stresses developed due to bending moment M, left hand side M, right hand side stresses. Now come to MR. I'll make the board ready and go for MR. Now, see, Roman 2, to find same colors, maintaining same color, MR for given cross section. As I told you, MR, note, powerful note. Now all the red color terms will come. Like what? Now you write here balance section, over reinforced section, under reinforced section, permissible stresses, all will come now. Because why? Because you are finding MR. Okay, now first note depth of neutral axis, that is, or we can tell actual depth of neutral axis, for given cross section, that is x, is already, that is x, blue color, that is x is already calculated. I told you, already calculated. I told irrespective of Roman 1 or Roman 2 stress or calculation or MR for x side x. Now x over. Now next step. Since to find MR, we need permissible stresses for given cross section. Very, very important. I should change the pen because it has become little light. For given cross section, this okay? Okay. For given cross section, that is what? That is, in singly reinforced section, we require FCBC max permissible and FST max permissible. But, right here, but for W reinforced section, there is no expression, easy expression based on FST. So don't consider. So therefore, for W reinforced section, it is sufficient if you find FCBC max permissible for given cross section. Find it in the same way as singly reinforced section. I told why. Because I already discussed about it. Singly or doubly, that all concepts are same. Or briefly, if you want to tell, very briefly, not much statement. What you do is find XC by the equation XC equal to KD, where K equal to neutral axis constant for balance section, that is given by K equal to 280 by 3 divided by 280 by 3 plus sigma st over. Get XC. Then compare your whatever x came for the cross section, that is the actual depth of neutral axis. Depth of actual neutral axis for given cross section with what? For given cross section, color problem here, with your XC. Okay, now briefly, case 1, your x comes less than XC. Right here, cross section is under reinforced. In which case, all reason I told you, stress in tension steel, you should write here. I am not writing. All given earlier. Tensile stress in or stress in tension steel will reach critical first. Or for under reinforced section, FST max permissible. Actually, it should be green color. Okay, not writing. It should be green color. Okay. What is the okay? FST max permissible equal to sigma st. Okay. But what is the problem? FST max. But we want FCBC max permissible. What to do? Use the relation relation M, this is also known for you. MFCBC by FST equal to X divided by D minus X. Substitute FST equal to sigma ST and get FCBC, which is our FCBC max permissible for cross section. Right here. Now, space problem, you should write somewhere there only. Second is very easy. Case 2. Your X comes more than XC. More than XC. Then cross section is over reinforced. Oh, then right. Stress in concrete will first reach critical. At that time, stress in steel will be less than critical. Or we want FCBC. Then directly FCBC max permissible equal to sigma CBC. Right that way. Sufficient. That is the answer. Now, but one problem is there. As per IS code limit state method, when X comes more than XC, cross section becomes over reinforced section. You cannot use the extra strength that I told. Working test, no limitation. Nobody has given it. But if you use that theory, I told you earlier, you should not use the AST for available AST, which is more than balanced steel. So you should consider part of it, and MR you have to calculate. That special thing I will tell in the class. That is, if you go to limit state approach, where if section is over reinforced, IS code want to restrict the strength to a balanced one, but that I will tell in the class when I do the numericals. But available theory, limit state IS code told, working test they are not told it. Therefore, general procedure are given. Now, this is class number 6 for you. Class number 7, I will find MR for an under reinforced section. Sorry, not MR. Class number 7, I will go for Roman 1. For a given cross section, apply BM. Find stresses. Only one question. Maybe on homework I will give. Class number 8, I will go for MR. 8 and 9. M for under reinforced, 9 for over reinforced. I will take one more class 10. Maybe people will tell tension side equation is not there. I will prove they are wrong. There is equation. Depends on that day. Okay. We will meet in class number 7 now. This is today 6. Everything go through. If you are serious, each and everything I told, right, make a neat fair copy before I start, before you go through next class. Then only it will be clear. Not listening to the class, nothing will be clear.